46, notice it's cosine inverse of -1. That's not possible, right? Because that's cosine of what angle would equal -2, excuse me. Right? That 46, if you look at page 270 and 46, it says theta equals cosine inverse of a -2. Well, that would say that the cosine of theta would equal -2. That's not possible, right? Because cosine goes from -1 to +1. So that's not, that would just has no solution. But we can take a look at. And that one you talk about pretty fast. 44. It's cotangent inverse of square root of 3 over 3. So remember, when you do cotangent and secant and cosecant, you got to convert it over to tangent, sine, and cosine. So, and what I usually do is I go back and say, write this as cotangent of theta equals the square root of 3 over 3. Right, everyone, if cotangent inverse of this is this, then cotangent of this is that, right? That's it. And then write this cotangent as tangent, and that's 1 over tangent, right? And the reason I'm doing it is because, I mean, you either understand tangent, or if you look tangent, sine, and cosine, or if you look at your calculator, that's all you got is sine, cosine, and tangent. You don't have cotangent, cosecant, or secant. So you got to translate it into this anyway. So, and then what do is invert this, and then invert that. That's 3 cosine, square root of 3. And then at this point, you can either figure out what theta is by just figuring this thing out, or else you can, but I have to rationalize the denominator. Okay. I got to get rid of the square root of 3. And that you multiply square root of 3 is square root of 3. I'm just going to see what kind of number I'm dealing with. So this is 3 square root of 3 over 3. So that's what I have, right? Now, you can either say, what is theta? That when I take the tangent of it, I get the square root of 3. That theta would be the theta that we're trying to figure out up here. Or else you can write it as theta is tangent inverse. But sometimes it's just easier to look at it this way. And if you don't recognize it doing it this way, if you use the calculator, then you'd want to write it this way and put it in as tangent inverse and get it. If you're just trying to figure it out, then and you don't see it here, then what you might want to do is say, well, that's sine theta over cosine theta. That gives me the square root of 3. And what angle would have a value of sine over the value of cosine that would give you that? Well, just from a sine, in order to have a square root of 3 in the numerator, the only common ones, and this is always dealing with common values, is the square root of 3 over 2, right? And then whenever the sine is the square root of 3 over 2, then the cosine is always 1/2, right? And whatever theta gives you this combination, and this thing would give you that square root of 3, right? Because you'd invert this. So what is the theta that gives you the square root of 3 over 2 when you take the sine of it, and gives you 1/2 when you take the cosine of it? Okay, everyone agree that it's 60 degrees, right? It'd have to be 60. So then if you're dealing with the radian measurement, it's either going to be theta is 60 degrees, or else you're going to, in radians, and this, because it's theta, it's 60. But if they had x, y, or z, then y would have to be pi over 3, right? So whichever one you're dealing with. Now what you have to do at this point is you have to make sure that you're in the right quadrant for this cotangent. And the cotangent is only defined in what area? From 0 degrees less than or equal to, I think it's strictly less than theta. Which is less than what? Pi? 180. Or 0 to pi. So if you're just kind of manually doing it, you have to try to figure it out. You got to do this much. Now, if you're using your calculator, you're still going to have to go down through and get it to this point and then put it in your calculator this way. I mean, you have to do this much. The rest of this is just so that I can figure out where I'm at. Does that make sense? If I should, if I'm right, I should be able to put this right in the calculator. I should be able to go in my calculator, go second tangent, oops. Second, inverse, and then do second square root 3. And this is in radian mode, not degree. Now I go second tangent. So you'd have to go that far if you didn't know what it was. The next set of problems, that's what they're asking you to do. So, do you have any questions on this, James?
Yeah, no.
Kind of.
Oh,
Okay. Well, it's just like you do it. You have to do it over again, and you got to do stuff on your own and struggle with it and look at the answer book. So this is, they're asking for theta equal cosine inverse of a negative 1, 3, 3, 8, 3, 1, 6. Now this is just, that's not, in order to do it by hand, you'd have to have something with the square root of 2 in it, or square root of 3, or, 2 or something, or 1. But this one is strictly a calculator problem. So what you're going to do with this one is just second the cosine inverse, and then and you'll have to put this negative sign. I'm pretty sure. If it isn't, it'll tell me it's an error. I'd say I read that as a 0. That's a 3. 3. That's is that 3/8? 4. 4 8 8 1 6. So it's 4. Oh, I didn't get another 3. 3 4 6. Now did I get the number in there right? And I got it. Now how in the world come it didn't do sine? It did S inverse.
It just moved over.
Did it move over?
Yeah,
okay.
fine.
So this is degree mode, so 97.67 degrees, and it doesn't tell me what value, where to run the decimal point out at. So that's what you're going to do there. Now, the arc sine is the same thing as sine inverse on 50, right? So you just put sine inverse for that.
They just put sine inverse, right?
I don't know. I don't. That is not for me. It's just that arc sine and sine inverse mean the same thing. And I don't know why. I really don't know what the reason is that they have a duplication there, and what the historical part is to it. But arc sine means sine inverse. So if you use your calculator, that would be just like this one. You just go sine inverse, put the value in there. Now 52 is going to involve a little bit more to it. Here it says theta equals cotangent inverse of 1.767 0.492. Now, the first thing you want to do when you do cotangent is you want to make sure that this isn't a negative. If it's a negative, then whatever you get as an answer, you've got to add 180 to it, or pi. This one is a positive, so you don't have to do it. The result that you're going to get is going to be the answer. So that's the first thing. Then what you want to do is, until you get comfortable with it, is write this thing as cotangent of theta is equal to 1.7670492. And then understanding that cotangent is 1 over tangent. Then if you invert this side, you invert this side. So this says tangent theta equals 1 over 1.7670492. And then you do theta is tangent inverse of 1 over 1.7670492. Now, once you get comfortable with this, when you look at this, you should be able to go right down and do this. I just went through it to show you that that's what you do. And then you say, my theta, I don't have to add 180 to it. Does that make sense? I just went through the process so that you could see, but it's always going to be, if you go cotangent inverse of something, it's going to be the tangent inverse of 1 over that. And if you don't believe it, just go down through that process. But after you do it a while, you just write this way. So then you're just going to go put, and it's a calculator problem, so you go second tangent, and then you put 1 divided by 0.767. Oops, and it says I did a mistake. And then I'm going to go to, and I put a decimal in there rather than a 0. So I put a 0. I still don't like it. What else did I do wrong? And I put a double bracket. Aha. Finally got everything right. Then I'll just make sure that was 52. Yeah. Now, let's look at 54. Cotangent now, because that's negative, we're going to have to go the answer plus 180. And what we know we have to do is from before, this is going to be tangent inverse of 1 over a negative 2.7733744. And then we have to add 180 to that. Because this tangent inverse of a negative is going to put us between 0 and a minus 90. And cotangent is going to be negative between positive pi over, or positive 90 and 180. So you have to do that.
And that's when we add the 180 in, like this step.
Whenever this is a negative, you're doing cotangent.
Right, but we wouldn't add it, like before you put it all over, you put the number under 1, because you're going from cotangent.
Yeah, you do the inverse of this one, tangent inverse, and then that's going to give you an angle. But the tangent inverse of a negative number is going to give you an angle that is between 0 and negative 90. But we want an answer between positive 90 and 180. So you got to move that over.
Okay.
And this is, see what I can kind of show you why. See, I might be able to. This is negative 90 and 90. And it's vertical asymptotes here, and the tangent is this way. But between 0 and 180, the cotangent is that way. So when you do 180, you do tangent inverse, you're going to get these values, which are going to correspond to these values. But when you're down here, you have to add 180 to it to get over here. Does that make sense?
Yeah, I can kind of see that.
Okay. So we'll do second tangent inverse of, and I'm going to put a negative because it won't make any difference whether the negative's in the denominator or the numerator. 1 divided by 2, 7, 7, 3, 3. Bracketed. Now I'll just make this a two-step. So it's going to be in minus 19 degrees, and then I'm going to add 180. And you could do that all in one process. You wouldn't have to. And that's, but remember that it's only when you this a negative cotangent that you have to add. All the other ones convert straight across. I'll just refer you back to page 265. You see, sine inverse is, they show you the interval. It's between minus pi over 2 and pi over 2, which is a minus 90 and 90. Now, sine is related to what? Cosecant. So when you convert cosecant inverse to sine inverse, you do sine inverse of the inverse of the argument, right? And notice that's going to be between minus pi over 2 and pi over 2. So the range is the same in your book. So you don't have to do any conversions. And likewise with cosine and secant, but when you go tangent and cotangent, you see it goes, tangent goes from minus 90 to 90, and cotangent is from 0 to 180. And that's why you have to do that adding 180. So, any questions on that? Let's see. I got this. The answer here was theta equals 160. Just have to always make sure that I got the right answer so that I'm not lying someplace. 56. Theta is secant inverse of a negative 5 e. So now the trick is you got to remember that secant is related to which, sine or cosine. So what you're going to do is theta is cosine inverse, because secant's related to cosine, and then you got to do 1 over negative 5.1180378. And both secant and cosine inverses have the same range from 0 to pi. So you're going to get, you don't have to do any corrections. So then it's just going to be second cosine. And I can move that minus sign up on top, out in front. Now if I entered everything correctly, 101 degrees. Now, the next set of problems there, it's saying real number value. And so what you have to do is change your mode, right? From degree to radian. And that's, when it asks you to do that, that's what it's telling you to do. So on 58, we can just, I don't know that we have to do these. You're just going to put what, sine inverse of that number in your calculator? Is that right? You do sine inverse of 0.81926. The 60, what are you going to do there? It's going to be the same thing as this, isn't it? 60, where it says y equals secant inverse of a negative 1.287164. You're going to do cosine inverse of 1 over that. And that'll be, and then it'll give you that, it'll give you a number, right? It's going to give you 2.46. It'll be pretty obvious if you're asked for radians that you got it in the wrong mode, right? Because it'll give you pretty large numbers. This is going to give you numbers between zero, either 0 to pi is 3.1416. Well, you'd be seldom you'd get a degree of 3 degrees, right? But you would never get a radian measurement of 15. It's going to be, if you're dealing with cosine inverse, it's going to be between 0 and pi, which is 3.1416. Or for sine, it's going to be from minus pi over 2, which is 1 point whatever that is, to negative 1 to positive 1 point. 2 into 3.1416, 1.87 something. So it'll be pretty obvious if you have it in the wrong mode that you got it wrong. Tangent would be the only one that, well, it's going to be, for tangent, it's going to be 1.8 to whatever it is, or it'll be a minus 90 to plus 90. Just a little bit about secant inverse. Remember that the secant, you could never get a number between, you can't do secant inverse of any number between minus 1 and plus 1. Because secant is that deal that goes like that, right? So you can't, if you're doing secant inverse or cosecant inverse of any number between minus 1 and plus 1, it'll give you an error. Because there's the secant of an angle never gives you a number between minus 1 and plus 1. If you look back where they give us the graphs for secant. if you look in sine and cosine, we can just kind of talk a little bit about this. For sine and cosine, if you look at on page 146, so you can never get sine inverse of a number larger than 1 or smaller than -1, right? Because the sine is never greater than 1 or less than -1. When you look at that sine wave, right? So if you did sine inverse of anything greater than 1, it'll give you an error. No such thing. And when you do it, sine inverse, it's going to give you an angle that's, if it's degrees, between -90 and +90, or -π/2 or +π/2. Cosine's the same way. You can't take the cosine inverse of a number greater than 1 or less than -1. Because when you look at it there. But it's going to give you cosine inverse of a number between -1 and +1. It's going to give you an angle that's 0 to 180 degrees or 0 to pi. Whichever mode you got to get radian. Is it making sense, Lucas? And then we go over to where they're doing tangent. If you look at tangent, let's see. In that chapter, yeah, tangent. They're showing you tangent function on 169. Notice at the very top of the page, when they do inverses, they're taking that blue line. That's the part they're at. So you can do tangent inverse of any real number, right? Because it goes from -infinity to +infinity. But you'll always get an angle between -π/2 or +π/2 or -90 to +90. Can you see? Do you understand what I'm talking about? Do you see there? Now, if you go to cotangent on 170, you see that's the range that you're doing inverses. That is the cotangent curve, but that's the range that you're doing inverses on, right? So you can do cotangent inverse of any number on the vertical axis, right? And get a number on the horizontal. But when you get that number on the horizontal, it's going to be 0 to pi or 0 to 180 degrees. So the inverse, you're taking the vertical and converting it over to what is it in the horizontal. Is that making sense?
Yeah, you're really gonna be looking at the,
Yeah,
it makes a lot more sense if you're looking.
yeah, that's why now if you look at the secant function, do you see the secant function? Notice that the secant function is only defined for inverses from 0 to pi, right? Because it's not a one-to-one function if you go further than that. But notice values between -1 and +1 don't exist when you do the secant. Right? So you can't do secant inverse of any number between -1 and +1. There are no angle relationships there. But you can do anything from 1 to infinity or -1 to -infinity. And then the same thing for cosecant applies. Are there, I'm going to go to the next section, which there you good with this stuff?
Yeah, wait, maybe I was just really tired on Friday.
Yeah. Well, it's just, you've seen it, maybe you worked on it a little bit, and then we're looking at it again, and then it's totally, to probably most of you, it's new. Some of maybe have seen it before, but yeah, it's totally.
All I'm having is getting started on the phone.
Yeah,
finding the starting point for it.
yeah,
And once I get going, it's fine.
yeah,
That's-
yeah. And, you know, if you get a hold of those videos, if that would help, or else if you can get one of these guys to help, or else, you know, you have a friend that is gonna help you. All right. So let's see, do I want, now, there's problems over on page 272. I'm not gonna do them because they require us doing, we could do 78 and 80 and that'd be it, because it requires the double angle formulas, which we never went over in chapter 5. You have to have those half angle and double angle formulas to do the conversion there. So I'm not gonna, you don't have to worry about 77 on. If we could have got through chapters 5, then we could have done it. We'd have the information to do that. Now, 6.2 is solving problems with trig functions that involve trig functions. And what I'm going to just do some problems, but there's a strategy on page 277, or an algorithm if you want to call it that. And it says, number 1, decide whether the equation is linear or quadratic in form so that you can determine the solution method. Number 2, if only one trig function is present, solve the equation for that function. Now, this is similar to doing algebra where you have variables, but your variable now is the trig function. Rather than saying x squared, you're going to say sine squared. And so that's, if you get to the point where you can transition that way, then you'll understand it, but it's just going to be a matter of being able to see it. Number 3, if more than one trig function is present, rearrange the equation so one side is 0, then try to factor. So it's just like the algorithm that says if you got a second degree polynomial, get 0 by itself, everything else on the other side, have it in descending order and see whether you can factor it. That's a similar kind of statement to this. Number 4, if the equation is quadratic in form, that's what I just talked about. Try using identities and change the form of the equation. So those are options that you have, and maybe as we do problems, you'll see what we do. Now, the first thing is concept checks, and it says refer to the summary box on solving trigonometric equations. That's the one I told you about. Decide on the appropriate technique to begin the solution of each equation. Do not solve the equations. I'm just going to give it a shot at solving the equations. Decide the method. Now, some of these are probably something that you can see quite readily. Now, this is a linear equation in sine x, and what you would use is you would get the sine x by itself on one side. So what I'm going to do is subtract the 2 from both sides, and then I get sine x equals 1. Now what I'm going to do is x then is the sine inverse of 1. Now what they would have to do is either you're going to get it in, you're going to be told to get the value that your calculator gives you, or they're going to give you a range. But your calculator, if you were to put this in the calculator, what would be the value of x that it would return if it were degrees or radians, you know? Now, remember, sine is from minus pi over 2 to pi over 2. And in that range, when you take the sine of what value gets you positive 1? 90 or pi over 2, right? So because it's x, you'd probably do pi over 2. If you were doing theta, you'd say 90. Theta is usually an angle in degree mode. X would be radian measurement. Now, number 4 is going to be a different methodology. Here's 2 cosine squared x minus cosine x equals 1. Now, this one, you could say, well, this is a second degree polynomial in cosine. And you could get 0 by itself on one side. And then you would say, well, this is in descending order of cosine, because it's cosine second, cosine first, and then cosine 0. And the leading numerical coefficient here, 2, is a positive. There's no common factors, so don't have to do that. And then you would say, is it a special, it's a trinomial, but it's not a special case. This isn't a squared term, because that would have to be a 4. And this would have to be plus. So it's not, now can you factor it by trial and error? And if you can, this is going to be cosine x, because when you multiply, FOIL it, cosine times cosine is cosine squared, right? And then the sign has to be plus or minus, because that's the only way you can get a negative here. And now what you do is you say the factors here are 1 and 2, and the factors here are 1 and 1. And what's the combination of 1 and 2 and 1 and 1 that gives me a difference of 1, because the signs are opposite? Well, 2 times 1 is 2. 1 times 1 is 1, and the difference between 2 and 1 is 1. So now what you have to do is the larger product has got to be negative. So these two 1s go here. That 2 has to be involved with the larger product, and it has to be negative, so that means that 2's got to be right there. Just like algebra, factoring algebra. Now what you do with that is, in algebra it says you take each factor and set it equal to 0, right? And then you solve that. So this says 2 cosine x equals minus 1, so cosine x equals a negative 1/2. Now, this is what you're asking, cosine inverse of a negative 1/2. Or you want to say, in the range of the cosine is defined between 0 and pi, where is cosine negative 1/2? Okay, but you know it's got to be radian. Okay, so it's 2 pi over 3. If you ask if that were theta, then it would be 120 degrees. Now, this one, yeah, well, I think it's not 180. Is it? Yeah. Cosine inverse 1. So it would be, no matter which way you called it, it'd be 0, either 0 degrees or 0 radians, right? at the beginning of that thing is where it's 1. So like number 6 is tangent squared x. Tangent x plus 2. Now, that's a second degree polynomial. Zeros by itself, no common factor. It's descending order, leading term is positive. Now, the first thing you'd want to do is you'd want to try, because it's not a special case, you'd want to trial and error it. But that don't work, does it? Two numbers times itself is 2, whose sum is 4. No such thing. Now you got two choices. You either use the quadratic formula, where you put tangent x equals a minus b plus or minus the square root of b squared minus 4ac over 2a, where a is 1, b is minus 4, and c is 2, or else you do a completing the square on that thing. Because I'm a completing the square person, that's where I go with it. So I would do tangent. Now if you're quadratic formula, you can get the same thing by doing the quadratic formula. But I move that 2 over. Then I would take half of this middle term, minus 4, and I'd add it. Minus 2 squared, and then I would add it over here. Now, this is a complete square. Minus 2, the quantity squared equals, and this is going to be positive 2, right? Then I take the square root of both sides, plus or minus over here. And then I have tangent x minus 2 equals plus or minus the square root of 2. Then tangent equals 2 plus or minus the square root of 2. Now, I'm going to have to do tangent inverse of 2 plus or minus the square root of 2. So it's going to be two answers. One is x is equal to tangent inverse of 2 plus the square root of 2. The other one's going to be tangent inverse of 2 minus the square root of 2. And I have to use calculator. I've used up our time, but that's what I can start there and work on. So this is the combination of algebra skills and trig skills. I guess I didn't get them picked out. I should have looked, but I was tired. It was a choice: nap or get. I'll get them Wednesday.
You're not class Friday, right?
No class Friday. Complete.